All right, today we're going to look at this concept of molar mass. In a previous video, you learned that 1 mole was equal to 6.02 times 10 to the 23rd atoms. And it doesn't matter what element I'm looking at. If I have a mole of it, a mole of carbon, a mole of oxygen, a mole of iodine, a mole of uranium, every one of them would have 6.02 times 10 to the 23rd atoms. Remember, a mole is a counting number. Just like a dozen equals 12, a mole equals 6.02 times 10 to the 23rd atoms. But we don't need to work with the concept of atoms very often. We do need to work with mass. And so it turns out that we can also define a mole as the mass in grams of the substance that we're looking for. So, how do I find the mass in grams of the substance? Well, I go to the periodic table. So, for example, if I go to carbon, mass of carbon is 12. So, 1 mole of carbon would weigh 12.01 grams. So, that means it has a molar mass of 12.01 grams per mole. If I look at oxygen, 1 mole of oxygen is equal to 15.99 grams, or it has a molar mass 15.99 grams per mole. Well, that's fine if we have a single element, but what happens when we have a molar mass of a compound? Well, it turns out you just count the number of atoms of each kind of element, like you've done in a previous exercise in counting atoms. And now we're going to add together the mass of every element that's in the compound. So the way that you start this is to look at the compound. So we're going to look at number 1, NABR. And the first thing we need to know is how many of each atom do we have? We have 1 sodium and we have 1 bromine because there are no subscripts, so it's assumed that there's 1. We're going to multiply the number of atoms by the mass of the atom that we find on the periodic table. So I need to go find the mass for sodium and the mass for bromine. If I look at my periodic table, sodium is here in group 1. It has a mass of 22.9. We're going to round that to 23. And then bromine is over here in our halogen column, number 17. Bromine is right here. It has a mass of 79, which we'll round to 80. So if we come back to our worksheet, we have 1 sodium that we said we would round to a mass of 23 grams, and bromine, which we said we would round to a mass of 80 grams. And then we simply multiply and add together. We have 1 sodium at 23 grams, 1 bromine at 80 grams, and so then we can simply add them together and say that 1 mole of sodium bromide would have a mass of 103 grams, or its molar mass is 103 grams per mole. Let's look at water right here, H2O. Again, count how many we have. There are 2 hydrogens because of that subscript, but there's only 1 oxygen. And then we would go to our periodic table and we would find the mass of hydrogen off the periodic table. Right? So here is hydrogen. We're going to use a mass of 1. And then oxygen is sitting over here. And we did that in our example earlier, and 15.99, which we're going to round to 16. So, hydrogen had a mass of 1 gram, oxygen had a mass of 16. But now we need to total out. There were 2 hydrogen atoms, so I have to account for the mass of both of those. So 2 times 1 is 2 grams. In water, 2 grams of every molecule is hydrogen. And then 1 times 16 gives me 16 grams. So 16 grams of every molecule of water is oxygen. gives you a total mass of 18, making water's molar mass 18 grams per mole. And then let's do one more that has a parentheses here. So you learn to count these atoms, right? So we're going to do number 11. We have 1 calcium. How many oxygen and hydrogens do we have? Well, in Mr. Wishart's video on counting atoms, you learned that this 2 right here applies to everything inside the parentheses. So inside the parentheses, there's 1 oxygen, there's 1 hydrogen, and this 2 applies to both of it, which would mean we have 2 oxygen and 2 hydrogen. But here's a way that you can look at it if the parentheses kind of get to you a little bit. Take this and expand it. What we have is Ca, and we have 1, 2 OH groups, right? And then if you count, you'll see there's an oxygen, and there's a hydrogen, and there's a hydrogen. And that works every time you have something like a parentheses. So now all we have to do is go to the periodic table and find the mass of calcium, oxygen, and hydrogen. Well, we know from an earlier problem that the mass of oxygen is 16 grams. The mass of hydrogen is 1 gram. We need to go find calcium. So let's go back to our periodic table. Calcium is over here in group 2. He's one of our alkali earth metals with a mass of 40.078, which we will round to 40. All right, 40 grams. And now we have all our masses, and we've counted off the number of elements that we have. 1 times 40 grams, 2 times 16 equals 32 grams of oxygen and 2 grams of hydrogen. And then we simply add them together to get 74 grams. Or that the molar mass of CaOH2, calcium hydroxide, is 74 grams per mole. And now it's your turn.